about file types. There are two types regular files, that is ASCII files and binary files. Okay, the ASCII files consist of lines of text. So if you open the ASCII files, you can read and understand the content of the files. And then similarly, if you print a ASCII files, and you can get you can read it directly. But on the contrary, if the files are binary files, this type binary files, and then if you print them, you may don't understand the content about the binary files, because we all know that every information are presented by binary, yes, numbers. Okay, this is the binary files. So some types, for example, this one, text files. This type, text files are typically ASCII files, yes, because when you open a text files, you can read the content. You can understand the content, yes. So text files are ASCII files, okay. There are two binary files. The first one is an executable file. The second one is an archive, but both files are binary files. So we can see that in an executable file there are 1, 2, 3, 4, 5 segments. The first segment is a header about the basic information of this file. Header. The second segment is text, the content, yes. Then data, location bits, symbol table. In the header, this segment, we can see that magic number, text size, data size, DSS size. So we can see that the header is about the basic information about of this executable file. Yes. So because for example, we know that the size, text size. We also know that the data size. This size is about this part. Yes, this size, and then the data size is about the size of this part. Yes. And the header is begins with a magic number. Okay.
Magic number?
Yes. It just means the beginning of a header. The magic number means that this file is a executable file. Okay. It is just a notation. A notation means that this file is an executable file. Okay. The second one is an archive file. So we can see that the file structure are different. Yes. These two files, their structures are different. Yes. For example, we can see that an archive file, we can see header, object module, and header object module. Yes, the basic structures are different. And in an archive file, the header records some information. For example, owner, size. module name. Okay. A file has its own attribute. There are so many attributes. We can read this table, focus on this table. For example, the protection attribute is denoted who can access the file and in what way. Some users are allowed to access this file, but some others may be prevented. Okay, which one? Who can access this file? Attribute protection. The second attribute is password. You can set a password for your file. Okay. So if you want to access the file, you must know the password. For example, a Microsoft Word file we can also set the password. Yes. Create attribute. From the name, we can see that this attribute indicates the ID of person who create the file. Okay, who created this file? Owner. This is the current owner of the file. There are some flags. There are flags. For example, read-only flag. Maybe these flags may be 1 bit, or maybe some bit, 1 bit or some bit about some specific information about this file. For example, read-only flag. If the value is 0, it means this file can be read or write. Okay, but on the contrary, if the value is 1, we can only read this file. So there are no 1, only 1 bit. Yes, 1 bit. Okay. There are so many attributes about a file. I think maybe you can spend some time to read this table. Okay. Okay, there are 11 file operations for the file. The first one is create. It means we can create a file. Okay. The second one is delete. The third one is open. If you want to read a file, you must first open it. Have you finished the operation? Then at the end, you should close this file. Yes, open. And do something, and then close this file. Okay. The fifth one is read. It means just we read the information, read the content about this file. If you want to write some content into the file, you can use the write operation. I think when you make a program, for example, by C language or Java language, I think you have learned that how to open a file, yes, and how to close a file. Okay. one append just like this its name means the information is appended to the origin file at the end of the origin file. Okay, appended. Seek means random access. Random access. We can randomly access the file. Okay. The last one is rename. We can change the name about the file. So let's focus on an example. The example is just to copy file abcxy. This is the command. Copy file abcxyz. This is the command. Okay. So its meaning is to copy the file abc to xyz. So maybe xyz already exists, maybe not. If xyz already exists, we just return xyz because we copied the content of abc to xyz. So it is called overwritten. Yes. The second case is that xyz doesn't exist. So you should first create the file. Yes, you first create the file xyz and then copy the content of the file abc to that of xyz. Okay. So when we write the program use C language, we can get that the items in this command, in this array, three items. Yes, the first one is copy file, the second one is abc, the last one is xyz. Yes, three items in argv. And then when we achieve copy file abc to xyz, we should declare some variables. Now there are 5 variables. The first two is fd, in fd and out fd. It is just used for the file description. We will get into details in the next slide. Okay, and the next two is RD count and reality count. So we know that these two variables is to record the number. The number is count. Okay. The last one is buffer. The buffer is used to hold the data read and yes, and it means that if we want to write the data into a file in the disk, yes, we first put the data into the buffer and then the buffer to the disk. Okay. So let's focus on the program to achieve copy abc to xyz. First we have learned this array. Yes, three. Yeah. There are 3 items in this array because our purpose is to copy file as abc xyz. This is the command. Okay. We just define a constant buffer size 4096. Yes, this is the bytes. Okay, this is the size of the buffer. The second one, this constant is just protection bits. Let's continue. We have declare buffer, yes, and each side is 4096. Okay, 1, 2, 3, 4, 5 variables. Okay, in order to achieve copy a file to another file, we declare 1, 2, 3, 4, 5 variables. First one, if argc is not equal to 3, we just exit. It means we terminate the program. This is because 1, 2, 3 items. Okay, so argc must be equal to 3. If it is not equal to 3, we should terminate this program because an error happens. Okay.
Not less, not more.
Yes, it's just an error. Then otherwise, this means the command is correct. Otherwise, we should open the input file ABC. Yes, because we want to copy ABC to XYZ. So we first open the file ABC, and then we check whether XYZ exists. If not, we create XYZ. Yes. If yes, we just open XYZ. Okay. So this one, we open the first and this one, it means the index. Yes.
Yeah.
The index one of argv. Okay. So we can return back to index one.
Index one is
Index
ABC.
one is ABC. Oh yes, that's right. And it is string. Yes.
Yeah.
The length of the input file. Okay, the command is open. We just use open function.
Yeah.
This is ABC string ABC. So this function is used to open the file ABC. Okay, we just return back. This one is a pointer. Okay. And the value of infd, if the value is smaller than 0, it means that we didn't open this file successfully. It means we failed. We failed to open the file ABC. So we just exit terminate. Okay, terminate the program. If we success, then we continue. Yes. And the next one, we create the output file. Now we just read the index 2 in the array argv. Its length its content is XYZ string. The name of the output file. We create, then return a value out fd. Similarly, if this value is smaller than 0, it means we fail to create this file XYZ. Yes, and we just exit. Otherwise, we continue. Okay.
The first in the whole part.
Only.
Yeah.
Read only. It means.
Read only.
Yes. It means the tab you open the file. This is only read because we read.
This is variable or anything else?
Read only. Okay. Read the content of this file ABC. This parameter is just the model opening operation. This one is the output. Means you can write something into the output file. Okay, this is the model. Okay, if we already we get there, it means that we successfully.
Every condition is.
Yes, continue.
Yeah.
We successfully open file ABC and create file XYZ. Yes, we just continue. Next line. This is a loop. Okay, always the loop because this is true. Yes, so we get into it. The function is the read, and this is EFD. EFD pointer to the file ABC, and the buffer, and the buffer size. It means we just read a block to the buffer. Okay, read where to read. From this parameter, okay, from here to read a block and into buffer. Okay.
Buffer is destination.
Yes, this destination. This is the source destination. And we just return a value, read count. It means how many we have read. Okay, good. So if this value, if read count is smaller than zero, it means that we have got the end of the file, or maybe an error happens. Yes, we didn't got a block, so we just break.
Okay.
Break means that the loop
Just terminate the loop.
Yes, terminated the loop.
Not program.
Yes. Otherwise, we just continue. Okay. Otherwise, we just continue next line. Next line is to call the write function. Okay. Write function means that we write the data in the buffer into the destination. Yes. Okay. Now the destination is the out FD, because out FD pointed to XYZ file. Yes, we just have created the XYZ file. This is the destination, and this is the source buffer. From buffer to destination. Okay, and this one, the RD count. We can get that the RD count is the value returned by the reader function. Yes, it means that how many blocks we have read from ABC file. Yes, so because we have read RD count blocks, so we just write this RD count blocks into out file. Yes. Okay. Next one. If this one means that how many blocks we have written from buffer to XYZ. Yes. So if the value is not larger than that means we didn't write anything. So we just exit. Okay. Otherwise we continue. Now we know that this part is used to open two files, and this part here is used to read and write. Read from one file, ABC file, to the buffer. Write from ABC from buffer to the XYZ file. Yes, this is the key point. This is the key point. So we have finished the copy operation. At the next step, what should we do? The next part we should do is to close. Yes, close the file. So this part is used to close the two files. The first one, this is the ABC file. The next one, this is the XYZ file. Okay? Open and do something and close. Okay? If you have finished the operation, you must close the files. Okay? Can you understand this? There are so many files in our disk, so we organize them. We get a directory. The directory about file. This is the simple one. The simple one only one layer. Okay, one layer or one layer. Because we can see there is only one root. And each file is a children node of the root. There is only one layer. Okay. Another type is to organize the files into a hierarchy directory. Okay, this is a hierarchy. We can see that this is the root, the root directory, and the first layer, second layer, and third layer, and fourth layer. Yes. So because in fact we just use the hierarchy directory system. So if we want to find a file, we must know the path. Yes, the path. For example, this one, we just from the root, and along this path, we can arrive at the destination. We just can get this file. Yes. So, if we want to get a file, we should know its name and its path. Yes. For example, there are three types: absolute path name. The Windows one. This is the Windows. We can see that we just use the separate slash. The slash from left upper to right lower. Okay. Left upper and right low. Okay, this slash. On the contrary, in the Unix operating system, yes, the slash just from the upper, right upper, and the left low. Okay, they are different. We just focus on this one as an example. It means that we from the root, and we can get a file user, yes, and then AST and mailbox. Okay. If the path begins with a slash, for example, begins with a slash, we just know that this is the absolute path from the root to the destination. Okay. So we just transform this path in the form of units. We only need to change the slash. Yes. This is the absolute path length, and then we can get a relative path length. It means that there is a working directory. Working directory means that now the directory you are working in. Okay. This is the working directory. We also call current directory. For example, if the current working directory is USR AST, this is the current working directory, and the absolute path is USR AST mailbox. Then, if we want to use the relative path name, this is the absolute path. Okay, this is the absolute path. This is the working directory. And now we use this tool. We can get the relative path. The relative path is just a mailbox. We can see that this path we didn't see a slash. Yes.
Yeah.
If the path begins with a slash, it means this path is absolute path.
Yeah.
On the contrary, if the path doesn't begin with a slash, so this path is a relative path. Okay, so you should know your current directory, and the current directory add the relative path. You can get the absolute path. Yes. You just append the relative path at the end of the current working directory. Yes. We just add a slash and a mailbox. Okay, we get the absolute path. So there are two key points. First, if the path begins with a slash, it is absolute path. Okay. On the contrary, if the path doesn't begin with a slash, it is a relative path. And the second point is that use the relative path and the current working directory, you can get the absolute path. Okay. In the operating system, each process has its own working directory. There are two special entries. We just use dot. Okay. So what does this dot mean? Dot in a path mean. If you see this one, see this dot in a path, it just means the current directory. It means that this one, this part, the current directory, you can replace it with only a dot. Okay. Dot in a path means current directory. And this one. This is called dot. Dot means go higher up of the directory. For example, this is the absolute path, yes, because it begins with a slash. This is the absolute path, and now we use this part, this one. Begin here and here. This is the command, yes. We can see dot. So dot means go higher up.
Yeah, go to parent. The beginning of the directory.
Yes. Begin from here. This is the working directory. And then if we use, this is the working directory, and then we use dot. So we will go to a pass, it means we are now in USR, because USR is the parent of AST. Is there any problem? Okay, and how up of the tree? So let's focus on this command. This command, we can see dot dot, yes, and this is the absolute path. So dot dot absolute path means that we will get into
light and dictionary.
No. This is dot dot. Dot dot means go high up.
Yeah, like their USR. Before
focus on this command.
Yeah, this command means the parent root directory of leaf.
Now from this one, we can know that we are now in directory.
Yeah.
Dictionary, and its parent is lab. And then we can see dot dot.
It means light parent.
Yes.
Yeah.
So the root is only lab.
Yeah.
Okay, because we will go higher up.
Yeah.
It's lab. Okay.
Dot dot means there are another root of the.
Yes. Dot means go to its father.
Yeah.
Okay. So the directory now is lab.
Yeah.
Okay. And so I have just tell you the meaning from dot dot to dictionary. Okay. But we will find that there is also a dot. So this dot means this is a
current directory.
Yes, it's the current directory.
Yeah.
So this command means we will copy files in lab into current directory. Okay. So I just know that dot means the current directory. We also know that the working directory also means current directory. It is USR AST. So this dot can be replaced by which one? Which one? I have just said we can divide this command into two parts. Okay, the first part is dot lab, and then dictionary. Yes.
Yeah.
Because dot means go to its father.
Yeah.
So now already. The path is just lab, yes?
Yeah.
This command is equal to this one, yes?
Yeah.
And then the second path is a dot.
Yeah.
Dot means current directory. So we can get that the current directory is USR AST, yes?
Yeah.
Okay, so it means copy the files in the lab and to AST. So we can replace this dot by using USR AST. Yes. These two special entries are very important. Okay, dot. Okay. This is the hierarchy file system. This one is the root directory. Okay, this is the root. So we can write the absolute path of Gene. We just begin from the root to user. Yes, and from user to Gene. Okay, so we can see that the absolute root is slash user slash Gene. Yes.
যন্ত্রটাকে কি দেখে তার সাথে যে ব্যাগটা আছে ওই ব্যাগের মধ্যে সে যন্ত্র কি দেখে খালি দেখতে পারবে কতক্ষণের সময় শেষ হবে এর তার কোনো
there are some operations about the directory. Just make the operations on the files is, for example, create here means create a directory. Okay. We can also delete this directory. Open, close. Open a directory, do something, and then close this directory. Okay. Read and then rename. Change the name of the directory and the link. Link means that a file can appends the same file appears 2 times in different directory. Okay, the same file can appear in one directory. It can appear also appear in another directory. Okay, the same file. For example, maybe you have a text file, and your text file is stored on one directory in C disk, and maybe it also stored in D disk, but it is the same file. So we just link them in the hierarchy tree. Okay. Let's learn some about implementing directories. The first one, left one, we can see there are 3 files. Yes, file 1, file 2, file 3. Yes, each file has its length. Then attribute, file attribute. We have learned many details about its attribute. Yes, this is the attribute about a file. Okay. File attribute, and this is the file name. This is the file name. Okay. The second file, file 2, entry length, attributes, and file name. We can see that the first file is project. yes,
Yeah.
project and budget, yes.
Okay.
This is the name of the first file, and then the name of the second file is personnel, yes, personnel, okay. The third file is full. This is the name. We can see that the first way to implementing directory is just we first store information about the first file, then the second file, and then the last one in sequence. Okay. About each file entry names, attribute, and file name, we can see that we just use the crossed rectangle cross to indicate the ending of the file name. Okay. We also said that this is free.
We can begin from there.
This is free. Free means that we waste space. For example, in file 2, this is the end of the file name, and these two blocks are free. We just waste the space. Okay. So how to solve the problem? It means that different files have different file names. Their names have different lengths, maybe short, maybe long. Okay, because maybe short, maybe long. So we wait the space. How to solve the problem? How to solve the problem? Maybe you can focus on the right figure.
Yeah. Heap.
Right figure. So you can compare these two figures to find that how to solve the problem of dynamicless file length.
We can put together
Yes.
like there first one, then second one, then third one.
Yes.
It is there. We can put together and just indicate the end.
Yes. Rectangle with a cross.
Yeah.
Yes. That's correct. The difference is that we put the file names together. And how to find that this is the name of
file 1, file 2.
Yes, we just use a ending location, the rectangle with a cross. Okay, so if we read these characters, and here we can get that this is the end of one file. And now we can get that this is the end of another file, and so on. And then we will find that there is a pointer. Is the pointer in the entry? This pointer indicates that where is the name of this file. Okay. This is the pointer. The pointer is just like the pointer in C language. It's the same. Okay. we use the pointer, we can get that where is the lamb.
You're pointing just from where it's started.
Pointer just record the address of the first one.
First one.
Yes, the address of the first one. Okay. So address of the first one, address of the second one. So we can quickly find the lamb. We use the pointer, we can get the beginning address. And we use this notation, we can get the ending. So we can get to the whole lamb correctly. Okay. Because these file names are put together, so we didn't with the space. Okay, with the space. So the second one just save the space. The first one, on the contrary, with the space. Yes. Okay. This is the implementing the directories of file names. Just put them together. The reason for this listing is that different multiple files have different lengths, maybe long, maybe short. Okay. 你等下还有课吗？
没有课。
没有课了。In this figure, we can link this to one. So this file has two paths. Yes. For example, the first path is just along this path. We can read here. The second path is just along this one. Yes. Two paths. It means that the same file appears twice. Okay, so we just add a line, link these two nodes. Yes. So we will find that the directory has a direction. It means from parent to children. There is in fact, there is a direction, okay, but there is no cycle. For example, maybe you think that these two parts comprise a cycle. No, they are not a cycle because not a circle. This one. Not a circle, because we have direction from top to down. Okay. If the direction are opposite like this one, then opposite we get a circle. But in the hierarchy directory, there are no circle because we have directions. Okay. Although in this figure we didn't see a direction, but in fact the direction is from parent to children. Okay. Okay, that's all for this afternoon.